Okay. Hello, my dear students. Last class we discussed the various properties and the formulas of derivative. Now today I'm going to teach you how to solve questions on derivatives. So we are going to start off with exercise 2 subdivision B. I'm using an old book, so in your new book you go to derivative and exercise 2 subdivision 1 section B. Is that clear? You will get the questions, no problem. Okay, so question number 1, subdivision 5. So the question is, differentiate this expression 2x cube plus 3x square minus 6x plus 4. So as you can see, all the variables are in terms of x. So we are going to use the first formula, that is d by dx of x to the power n is n dot x to the power n minus 1. So you are going to start by writing let y equal to this. So differentiating with respect to x. So differentiation of y will be dy by dx. So since there is a plus and a minus sign in between, you have to differentiate them individually. So d by dx of 2x cube plus d by dx of 3x square minus d by dx of 6x plus d by dx of 4. Now property 1 says whenever there is a constant term, the constant term comes in front. So 2 is a constant, comes out. So 2 d by dx of x cube plus 3 d by dx of x square minus 6 comes out. So d by dx of x plus d by dx of 4. Out here 4 does not come out because the property 1 says the constant term comes in front if there is a function. So 4 is just a constant, there is no function at all. So the differentiation of 4 will remain as it is. Is that clear? So let us apply the formula 2 as it is. What is the differentiation of x cube? Differentiation means you are breaking the function, so it gets reduced by 1. So the formula says the power comes in front. So this becomes 3 dot x to the power 3 minus 1. So once you apply the formula, this d by dx will vanish. Plus again 3 is a constant as it is. Differentiation of x square, 2 comes in front. So 2x, 2 minus 1 minus 6. Differentiation of x, direct formula is there. Particular case number 1, differentiation of x is 1 and differentiation of 4 is constant is 0. So your answer is 3 2s are 6, 3 minus 1 is 2 plus 3 2s are 6, x 2 minus 1 is 1 minus 6. So this is how you use derivative to differentiate the function, make it small. So this is section B, question number 1, subdivision 5. So what did you learn? That the question will be of the form y equal to fx. That means y will be on the left, x will be in the right. If there is a plus or a minus sign, we have to differentiate them one at a time. Is that clear? One at a time. And after that, you simply have to apply the formula. Question number 6. The question is 2 root x plus 3 by x minus 3 by x plus 4 by x square minus 1 by x cube. So this is the question. So as you can see, all the variables are in terms of x, so I'm going to use the first formula. Is that clear? But the problem out here is, in order to use the first formula, x has to be in the numerator, but x is in the denominator. So that is the first thing I need to simplify it. So let y equal to this. I'm not going to differentiate, I'm going to simplify 2 root x because I know the differential root x minus 3. I'm not going to take x up because I know the differentiation of 1 by x plus 4 x square goes up and becomes x to the power minus 2 minus x to the power minus 3. Is that clear? Now what we are going to do is we are going to apply the formula directly without writing d by dx. In the first problem, I showed you how we have to differentiate one at a time by writing d by dx. Now, we are not going to write d by dx but differentiate it individually. Is that clear? So, see, differentiating with respect to x, differentiation of y is dy by dx. See, instead of writing d by dx of 2 root x, I am going to apply the formula directly. So 2 is a constant, I am just skipping one step. So 2 is a constant, or if you want me to write that, I am going to write it, no problem. From the third problem, I am not going to write. So d by dx of 2 root x minus d by dx of 3 by x plus d by dx of 4x to the power minus 2 minus d by dx of x to the power minus 3. Now property says before you apply the formula, the constant comes out. So 2 comes out, d by dx of root x minus 3 comes out, d by dx of 1 by x plus 4 comes out, d by dx of x to the power minus 2 minus d by dx of x to the power minus 3. Now help me apply the formula. 2, we got a direct formula for this. The formula which I have given it to you. Particular case number 2, root x is 1 by 2 root x. I explained how you got this also. Minus 3, differentiation of 1 by x is particular case number 3. It is minus 1 by x square plus 4. Now differentiation of x to the power minus 2. The power comes in front, so you get minus 2 x to the power minus 2 minus 1 because the power gets reduced by 1. Similarly, this minus 3 comes in front, x to the power minus 3 minus 1. So see what you're getting, 2 and 2 gets cancelled. So 1 by root x as it is, minus into minus is plus, 3 by x square, plus into minus is minus, 4 2s are 8, x to the power minus 3 plus 3 x to the power minus 4. So you can simplify this further by making this positive, and in order to make this positive you have to take x cube in the denominator. Is that okay? So this one was question number 1, subdivision 6. So in a similar way you can solve the remaining questions from question number 1. Now let us move on to question number 2. Question number 2. In question number 1, you learned to differentiate or apply only for formula number 1, that means x to the power n. Now in question number 2, you learn other functions also. So question number 2, subdivision 5. The question is x to the power 4 plus 4 to the power x plus log x. So how do I start? Let y equal to this. So differentiating with respect to x, differentiation of y is dy by dx. Since there is a plus sign, so I have to differentiate them one at a time. So d by dx of x to the power 4 plus d by dx of 4 to the power x plus d by dx of log x. You can skip this step by just instead of writing this d by dx, you would have directly written differentiation of x to the power 4. Formula number 1, 4 comes in front. 4x to the power 4 minus 1 is 3 plus differentiation of 4 to the power x. Formula number 3, d by dx of a to the power x. For you all, I am writing, I have already given you the formula, but still again I am writing it. So it's a to the power x log a. So it's going to be 4 to the power x dot log 4 plus differentiation of log x is 1 by x. So whenever there is a plus or a minus sign, you need not write d by dx individually, rather you can apply the formula directly. Is that clear? So what you could have done is, you could have easily written differentiating with respect to x in the previous questions also, and instead of writing d by dx, d by dx, d by dx, you could have directly written the answer. Since you are doing it for the first time, so this is how you are going to use the steps. Once you get used to it, you can skip the differentiating step. Okay, this is question number 2, subdivision 7. It is 2x to the power 3 by 2 minus 3e to the power minus 1 by 2x plus 2 to the power x. So this is the question. So I'm gonna differentiate this. So I'm gonna start by writing let y equal to, so next step would be differentiating with respect to x. Differentiation of y is dy by dx. So instead of writing d by dx, I'm going to do it directly. Is that clear? So how do we do it directly? So 2 is a constant, comes out. Differentiation of x to the power 3 by 2, formula number 1. So what is going to happen to the power? The power comes in front and you subtract 1 from the power. Done. Next term is 3 e to the power minus 1 by 3. So formula number 2, which says d by dx of e to the power mx equal to m dot e to the power mx. That means, see, 3 is a constant, comes out. So this is e to the power mx. So this m comes in front. So you get 1 by 3 dot e to the power mx is 1 by 3x plus 2 to the power x. See the difference between these three formulas. Out here, base is x, power is constant. Formula number 1. Out here, base is e, power is x. Formula number 2. And out here, base is a constant, power is x. Formula number 3. That means a to the power x. So what is the formula? It's a to the power x log a. A means the constant. So 3 and 3 gets cancelled. 2 and 2 gets cancelled. So your answer 3x LCM is 2. So 3 minus 2 is 1. 3x to the power 1 by 2 minus into minus is plus e to the power minus 1 by 3x plus 2 to the power x log 2. So this is how you differentiate a function when there's a plus or a minus sign. So in a similar way you can do the remaining questions. I'll be sending you the solution of all the questions in the PDF version. Is that clear? It's just that you have to go through the solution, understand it, memorize the formula and do it in your fair copy. Okay, now we move on to question number 3. Question number 3 is a bit tricky because they are telling us to differentiate x into e to the power x. You start by writing let y equal to this. You know the differentiation of x is 1 and the differentiation of e to the power x is e to the power x. But you cannot write this because there is a multiplication sign. So I have to use product rule. What are we supposed to use out here? Product rule. So this becomes your u and this becomes your v. So what do I get? Differentiating with respect to x. So get dy by dx equal to product rule. Product rule says whenever there's a multiplication sign, u constant differentiate v. Now v constant differentiate u. So which one is your u? U is x dot d by dx of e to the power x plus e to the power x dot d by dx of x. So x as it is. X, you are not going to apply the formula for x because this we are treating as a constant. So differentiation of e to the power x is e to the power x plus e to the power x constant and differentiation of x is 1. So for the first part you have to apply the formula and for the second part you need not. Is that clear? That means the first function remains constant. You don't apply the formula for the first term, you apply the formula for the second term. Is that clear? So what is common out here? E to the power x. So what do you get? X plus 1. So this is called product rule. What is it called? Product rule. So you are going to use this rule whenever there is a multiplication sign between two functions. With the same concept in mind, let me do one more. It's 2x plus 3 open bracket x square minus x plus 2. I'll be sending you the solution to all these questions in PDF. So please go through it. So let y equal to this. So since there's a multiplication sign, you take this as u and this as v. So what do I get? Differentiating with respect to x. Y, differentiation of y is dy by dx. So tell me the product rule. It is u d by dx of v. I'm writing this so that you all understand. V d by dx of u. So what is u? U is 2x plus 3. D by dx of v is x square minus x plus 2 plus v again x square minus x plus 2 into d by dx of 2x plus 3. So help me differentiate this. 2x plus 3 is a constant, so as it is. Now apply the formula out here. X square, what happened to this 2? 2 comes in front, so you get 2x minus differentiation of x is 1 and differentiation of 2 is 0. Finished. Plus x square minus x plus 2 as it is. I just want you to see the difference between these two. Both functions are same. For the first you are differentiating it, for the second you are keeping it constant. Is that clear? So you don't apply the formula in both the cases. Into, like see, for this particular case, this function was constant, so you did not apply the formula, but out here you have to differentiate. So 2 as it is, differentiation of x is 1 and differentiation of 3 is 0. So your final answer is multiply, open the bracket, 2 2s are 4x square minus 2x plus 6x minus 3 plus 2x square minus 2x plus 4. So when you simplify this further, what do you get? 6x plus 2x plus 1. So this is how you solve a question using product rule. So next up we are going to learn quotient rule. Question number 4, subdivision 4, it's e to the power x plus 1 divided by e to the power x minus 1. So you start by writing let y equal to this. So this is quotient rule, u by v. So how do you apply this quotient rule? We write differentiating with respect to x, differentiation of y is dy by dx. The rule is v square v d by dx of u minus u d by dx of v. So please put in the value of u and v. What is v? E to the power x minus 1 d by dx of u is e to the power x plus 1 minus e to the power x plus 1 constant, same as product rule but there is a minus sign, d by dx of e to the power x minus 1, and the denominator has to be the first function, e to the power x minus 1 whole square. Now simplify this, e to the power x minus 1 as it is. What is differentiation of e to the power x? It's e to the power x, differentiation of 1 is 0, done, minus e to the power x plus 1 as it is. Again differentiation of e to the power x is e to the power x minus 0, divide the whole thing by e to the power x minus 1 whole square. The final step, e to the power x plus 0 is e to the power x, e to the power x minus 0 is e to the power x. So if I take e to the power x common, what do I get? E to the power x minus 1 from here, minus this is gone, so e to the power x, since there is a plus sign, minus into plus becomes minus 1 divided by e to the power x minus 1 whole square. So this and this gets cancelled, so minus 1 is minus 2, so minus 2 e to the power x divided by e to the power x minus 1 whole square. So this is called quotient rule. What is it called? Quotient rule. Before I move on to the next question, whenever there is a division sign, you are not going to apply the formula directly, but we have to apply the property first, and this is called quotient rule. Okay, this is question number 4, subdivision 5. Y equal to x square plus 1 x square minus 1. So you start by writing let y equal to this. So you know what you're supposed to do. This is u and this is v. So differentiating with respect to x, what's the differentiation of y? dy by dx equal to quotient rule, it's v square, that means x square minus 1 whole square, v x square minus 1 d by dx of x square plus 1 minus x square plus 1 into d by dx of x square minus 1. So this is what v d by dx of u minus u d by dx of v. So help me differentiate x square minus 1, differentiation of x square is 2x and differentiation of 1 is 0, minus this is a constant, so as it is x square plus 1 constant, again differentiation of x square is 2x minus 0, divide the whole thing by x square minus 1 whole square. So what is common from the numerator? I can see 2x common, so 2x plus 0 is 2x, so 2x common, so what is left? x square minus 1 minus x square minus 1 divided by x square minus 1 whole square. So x square and x square gets cancelled. So minus 1 is minus 2. Minus 2 into 2x will give you minus 4x divided by x square minus 1 whole square. So this is called quotient rule. So my dear students, as you all know, the name of the chapter is derivative of a function, exercise 2 subdivision 1. This is section B. I have completed question number 1, 2, 3 and 4. So the remaining questions you please try it on your own, and plus I'll be sending you the solution of all the questions, and if you have any problem you text me, I'll explain it and send it to you. Is that clear? Thank you so much.